Okay, good morning everyone. So today is another lesson on physics. It is the 3rd of March 2021 and we are doing the centre of mass today. So just to start us off, I'd like to see how many words you can make out of the word centre of mass. And then once you've done that, explain the difference between mass and weight. So if you go and do that now, then come back. And then I'll whiz through the learning objectives, keywords, and then I'll go through some of the words that I came up with for this word. So pause the video now and go and do that now. Okay, so the learning objectives for today's lesson, we're going to recall Newton's 3 laws of motion. So you'll remember that from a previous lesson, hopefully. Describe what centre of mass is and find the centre of mass in regular shaped objects. And be able to find the centre of mass in irregularly shaped objects. Now that is the bronze one at the top, then it's silver and then it's gold. For some reason changing the background to black has messed up my colour scheme on these 3 objectives as well, quite annoyingly. The keywords for today's lesson are plumb line, regular, irregular, symmetry, pendulum and Newton's laws of motion. Okay, so let's go through some of the words that I came up with. So obviously you've got centre of mass. You're not going to get a point for that. Cent, can, cat, cast, form, font, fear, fee, mast, mat, mean, meant, fear, neat, me, and then all the rest of them. Got things like storm, steam, team, rent, scent, steer. You could have made a lot of words out of that. Okay, so mass versus weight. So mass is a measure of the amount of material an object is made up of. It is measured in kilograms, which is kg. Weight is the force of gravity on an object, and it's measured in newtons. So don't confuse these. Remember, mass is what you use as a measurement for scales. So if you step on a set of scales, you're not measuring your weight, you're measuring your mass, because it's the amount of material you are made up of. Weight is the force of gravity on an object. So let's go back over the laws of motion that Newton came up with. So his first law of motion stated that objects at rest remain at rest, and objects in motion remain in motion, until a force is applied to said object. So, got polar bear here, I've just fallen over, but he would keep moving because he slipped over until a force is applied to him in the opposite direction. So that could be friction, air resistance, running into a solid object, it could be anything. It's just, it needs to have something so that it will stop. So objects in motion tend to stay in motion. Objects at rest tend to stay at rest. That is the first rule, first law. Objects also tend to resist a change in motion, and this is called inertia. So this is something that I haven't introduced before, but you will know it now. So objects resist a change in motion, and it is called inertia. So for example, this person is pushing with 2 newtons of force, and the inertia is 2 newtons of force. So you need to push with a force of more than 2, so 3 or more, in order to actually get any results with the movement. If we go back to the astronaut scenario, remember I brought an astronaut in, well, not literally, but I included an astronaut in my PowerPoint a few lessons ago. So an astronaut in outer space will continue drifting in the same direction at the same speed indefinitely, until acted upon by an outside force, which is unlikely to happen in space. Let's put it that way. So Newton's second law, so he found that F equals ma, so force is F, mass is m, and acceleration is a. So to find out force, you would do force equals mass times acceleration. You can also do an equation triangle. So if we draw out a triangle here, and then we have force at the top, and then we put a line to say that it's divided and then we put a line here. You can even put a time sign there to remind yourselves that you times these two. So to find out acceleration, you would do force divided by mass. To find out mass, you would do force divided by acceleration. And to find out force, you do mass times acceleration. So that is the original formula, but that is how you would rearrange that. So I live by these equation triangles. I find it is really helpful to see it like this because you cover up the one that you want to find out. So say I wanted to find out acceleration, you cover that up, cover the A up with your hand, and you can see that you're left with force and mass. So you do force divided by mass because you've got the line there. Okay, so these are the units. So your force is newtons, your mass is in kilograms, and your acceleration is meters per second squared. So Newton's third law. So he stated that for every action there is an equal and opposite reaction. There is a video here which I'll put in the description box about a rocket taking off and showing the opposite reactions and equal reactions. So now I just want to do a quick recap and assess your current understanding of those laws. So I'd like you to go through these questions. So what are the three laws? For every something, there is a something. If a car has 25 newtons of inertia, what is the maximum force you can apply without it moving? What force would need to be applied to make it move? So that relates to question number 3. Objects at something tend to stay at something. Objects at something tend to stay at something. So do those questions, pause the video here, and then we'll go through the answers. Okay, so make sure you have a green pen or different coloured pen to what you used originally, and let's go through the answers. So the first one is about the 3 laws of motion. So the first law stated that objects remain at rest. Objects at rest remain at rest. Objects in motion remain in motion until a force is applied. The second one is F equals ma, so force equals mass times acceleration. And the third one states that for every action has its equal and opposite reaction. So that would be the answer to number 2 as well. So for every action there is an equal and opposite reaction. If a car has 25 newtons of inertia, what is the maximum force you can apply without it moving? That would be 25 because you are applying an equal force but not an opposite force. What force would need to be applied to make it move? That would be more than 25, so 26 and above. And objects at rest tend to stay at rest. Objects moving at motion tend to stay at motion. So what is the centre of mass? So here we have a little picture with someone holding, it looks like an aeroplane or some sort of bird, and it is clearly balanced, so it is on its centre of mass. So centre of mass is the point at which the mass of an object is thought to be concentrated. That is your definition for centre of mass. When a suspended object comes to rest and all the mass is under the point of suspension, it is called equilibrium. So we have Miley's missing clothes, covered her up there, and her missing clothes there. So we've got the equilibrium here because she is sat on there and there is nothing happening. So she's a suspended object and she's come at rest. So all the mass is under the point of suspension. And then the non-equilibrium is this one. So how do we locate the centre of mass for a symmetrical object? Well, you can draw lines of symmetry for a regular object and all of the lines will cross at one point, and that is the centre of mass for the object. The object will be balanced under that centre point. So if you've got a circle, just draw the lines through the middle, and the middle point is the centre of mass. Same for the square, you just keep drawing the lines, and when they cross over, that is your centre of mass. What I'd like you to do now is, hopefully you have access to a printer. If not, you can draw these shapes in your book or on your bit of paper that you're writing on, and draw these objects with a pencil, and then draw lines of symmetry to locate the centre of mass. And I will check those centre of mass drawings when you hand in your work. So, symmetrical object is along the axis of symmetry. What about an irregular shape though? What can we do for an irregular shape? Well, here we have an irregular bit of fabric. It's a sheet of material, and what we would do is make a hole in the middle, or make a hole in the material, somewhere in the material, hang a piece of string from it with a weight on the end so you can trace the line, which is called the plumb line, and make another hole in a different place and do the same thing. And then where they cross is the centre of mass of that object. I will put a video in the description box so that you can actually see this in action, because it's quite hard to explain theoretically. You need to be able to see it in action. And for your plenary, I am going to set you some work to do. So you've got some exam questions which I'll attach to the assignment that I'd like you to complete. And I will see you next lesson, which I believe is tomorrow on moment and equilibrium. And that is our last online lesson before I actually get to meet you in person, which will be nice.